Physics, Part 187. Very often the single slit diffraction equation for light is expressed in the form theta is equal to n lambda over A. Making use of the sine theta approximation, but take care this approximate form may not apply to the diffraction of other types of waves such as sound or water waves, where the wavelength may be closer in a magnitude to the width of the aperture and diffraction angles are larger. We've got an example for you. Calculate the angle between the center of the diffraction pattern and the first minimum when the light wavelength 6 nanometer passes through a slit 0.10 millimeter wide, using sine theta which is equal to n lambda. We have sine theta which is equal to n lambda over A. Substituting sine theta is equal to 1 into 6.0 into 10 to the power raised to minus 7 divided by 1.0 into 10 to the power raised to minus 4. Don't forget to convert the nanometer and millimeter to meter. That is 0.0060 and theta 0.34 degree. Using the sine theta is equal to 0 approximation, we would have obtained theta is equal to n lambda over E is equal to 1 into 6.0 into 10 to the power raised to minus 7 divided by 1.0 into 10 to the power raised to minus 4, which is 0.0060 rad, which is equal to 0.34 degree. Now it's your turn. Number 1, calculate the angle between the center of the diffraction pattern and the first minimum when a sound wave of wavelength 1.0 m passes through a dome 1.2 meter wide. Calculate the wavelength of the water waves which on passing through strap 5 centimeter wide, which passing through a gap 5 centimeter wide create a diffraction pattern such that the angle between the center of the pattern and the second order minimum is 60 degree. The diffraction grating. A diffraction grating is a plate on which there is a very large number of parallel, identical, very closely spaced slits. If monochromatic light is incident on this plate, a pattern of narrow bright fringes is produced. Although the device is called a diffraction grating, we shall use straightforward superposition and interference ideas in obtaining the expression for the angles at which the maxima of intensity are obtained. The figure shows a parallel beam of light incident normally on a diffraction grating in which the spacing between the adjacent slits is d. Consider first ray 1 and ray 2 which are incident on the adjacent slits. The path difference between these rays when they emerge at an angle theta is d sine theta. To obtain constructive interference in this direction from these two rays, the condition is that the path difference should be an integral number of wavelengths. The path difference between rays 2 and rays 3 and rays 3 and rays 4 and so on will also be d sine theta. The condition for constructive interference is the same, thus the condition for maximum intensity at angle theta is d sine theta is equal to n lambda, where lambda is the wavelength of the monochromatic light used and n is a whole number. When n is equal to 0, sine theta is equal to 0 and theta is also 0. This gives the straight on direction, or what is called zero order maximum, When n is equal to 1, we have the first order diffraction maximum, and so on.